Hi, everybody. Good morning, good afternoon. Welcome to our SISC special guest webinar with Synopsys, the Software Integrity Group. Let me see here. Just making sure I'm trying to share my screen. There we go. This is Tracy Berardi, Program Manager of SISC. Great. Sorry about that. My computer is just catching up with me. Today's webinar is Give Developers Early Feedback to Identify Security Issues with our friend Synopsys. Synopsys has been a long-time contributor to software quality standards development at SISC, as well as in other software assurance communities of practice. And today we're going to be talking about static code analysis and how to integrate it effectively into the development tool chain. With the help of Synopsys, we've developed code quality standards for measuring security, reliability, performance efficiency, maintainability, and we have a brand new measure around data protection and privacy that we'll also talk about today, specifically how you can analyze source code for these critical weaknesses, through SISC and OWASP, et cetera, other standards in this space. So we're really looking forward to this presentation. We'll talk about how Coverity offers support. So we've uploaded in the handouts tab, there's a copy of the slides, so you can grab those. We'll also have time for Q&A at the end, so feel free to enter your questions in the questions tab. We have some resources that the Synopsys team sent over, so we'll get those sent out to you afterwards as well, a little more product information. And for our guest speakers today, there's Mr. Ashutosh Kumar, he's in product marketing, and Mr. James Croall, Director of Technical Product Management at Synopsys. So I'm going to go ahead and hand this over to Ashutosh and make you the presenter so we can get started. Thank you guys for joining us today.
So can you see my screen?
Yes.
Okay, I will go in the presenter mode and start. So thank you everyone for joining today. Two main topics are being covered in today's webinar. I will take you through the discussion on the evolution of application security paradigm, and James will then continue the presentation talking about how you can use Coverity to give feedback to the developers in their IDE as they are coding, as well as in the pull request. He will also show you a quick demo for each of those. So I want to start with a couple of quotes from the book, The Phoenix Project by Gene Kim. Imagine the situation from the book. One morning, the payroll department finds that the entire payroll system is broken. Upon further investigation, the IT lead finds that developer made a last-minute encryption-related change, which led to this application failure. That payroll system relied on employees' social security numbers to disburse salary, which they could access from the employee database. The security manager, concerned about an upcoming audit, pushes the developer to encrypt the social security numbers stored, so a developer is forced to incorporate some last-minute changes before going on vacation to comply with the law, which breaks many other dependent applications. This is where the first quote refers to the state of mind of the IT lead. The only thing more dangerous than a developer is a developer conspiring with security. The two working together gives us means, motive, and opportunity. And the second quote, compliance is not optional, it is the law, and my job is to keep them out of orange jumpsuits. So I did what I had to do. It's a statement from their security manager defending why the change was made last minute. So that brings us to the perception that used to be around security. Security policies used to be primarily governance-driven, focusing on rules and gates and risk optimization. And such practices were waterfall-inspired, incorporated out-of-band security, and were highly centralized. That brings us to another quote from the book, that in any value stream, there is always a direction of flow, and there is always one and only constraint. Any improvement not made at that constraint is an illusion. I love this quote because it highlights a critical aspect in shaping security practices as organizations chase after agility and speed of application delivery. In the context of the situation described in earlier quotes, it highlights that security practices were considered one of the reasons slowing down the SDLC and thus needed improvement. You're trying to abide by the law and thus need to perform all the tests to meet compliance. However, the out-of-band security testing leads you to find security issues very late, and then it goes back to the developer to fix the issue last minute, resulting in delays in shipping the application. This used to be state of security practices and needed changes to meet the speed and agility requirements of the modern day SDLC, which leads me to my next section on the evolution of security practices. Today's security practices are being driven by engineering teams. They focus on the agility of SDLC, maintaining the feature velocity. These practices not only optimize for risks, but also for business objectives, are driven by metrics and strive for continuous improvement. Security testing needs to be fast and unobtrusive and performed inline in a decentralized manner where everyone is responsible for application security. Different teams use different tools as they find the right tool for their job. To expand further on that, in a typical SDLC, development team wants to scan their code without leaving their development environment. That is their IDE. So security tools such as SAST tools are being adopted to help developers write more secure, high-quality code without needing to leave their IDE. Security teams want to scan projects independently and to be able to see high-level reports for audit compliance purposes. They are probably not the experts in running build configurations, etc. So they would want a push button solution, like the ability to scan by simply pointing to the source code. QA DevOps teams want to integrate automated security testing into entire pipeline and may use these tools as a gate to fail the builds, create issue tickets, etc. SAST tools such as Coverity provide you with ways to shift left and start giving developers feedback early on, starting from IDEs to pull requests so that you can reduce the number of security issues getting into production. So who can benefit from using these SaaS tools such as Coverity? If you are responsible for managing the entire organization security, you want to protect the company's reputation and ensure that incidents like data breaches, etc., can be avoided. DevOps managers are concerned about the speed and reliability of the SDLC, so they are looking to ensure that they can sustain production velocity without compromising on security. Development managers are concerned about software robustness, delivering a product with minimal defects and reduce project risks from late-stage defects. Developers are under tight deadlines to finish writing their code with high efficiency and minimal rework. Coverity is a SaaS solution very well suited for these personas in your organization. It is comprehensive in terms of providing a broad range of identification capabilities for security vulnerability and quality issues, provide extensive language coverage and framework support, and security standards so that you can meet your compliance requirements. It can be easily integrated into popular IDEs, SCMs, bug tracking systems, and various other elements of CI/CD pipelines. It uses patented analysis techniques to identify security and quality issues with high accuracies and low false positive rates so that your developer's time is not wasted looking at the false positives. You have the flexibility to analyze with or without build. You can also utilize high-fidelity incremental analysis via the CodeSite IDE plugin and can also scale easily for very large projects. You can deploy it as per your needs, either on-premise or as a SaaS offering via Polaris software integrity platform. There are dashboarding and reporting capabilities to help you track projects, assess risks, and prioritize fixes. These are some of the examples of Coverity capabilities in languages, standard support, and elements of SDLC workflow. James will tell you a little bit more about how Coverity supports SISC, automated source code data protection measure, which Tracy was talking about. Over to you, James.
Thanks, Ashutosh. So, Coverity supports includes support for 6 new automated source code data protection measures and is able to detect all 36 parent weakness categories. As you'll see in the demo, all of this information is presented within and throughout the Coverity user interface. And with scripts, we can generate reports that will show compliance with the standard. Now, on the right hand of the screen, I've also highlighted part of our user interface, which is where we organize weaknesses by the CWE technical risk indicators, which our customers really appreciate because it allows them to see, in just really plain English, what would the impact be if one of these weaknesses were to be exploited. And so things like unauthorized reading of files, directories, and memory, right? This is squarely in the realm of the automated source code data protection measures. And you'll see the actual interface in a few minutes when we get to the demo.
Thanks, James. Yeah, thanks, James. So for a security team, Coverity can help you reduce security exposure in your apps, reduce project risks by finding problems earlier, and lower your software development costs. Developers want to see accurate and actionable findings. They don't want to switch tools to learn analysis separately, so it should be easily integrated into their development environment. Coverity provides a large library of checkers to give you a depth of analysis in finding security and quality issues with high accuracy within developers IDE. The CodeSite IDE plugin, which you will see the demo in a few minutes, has integrated e-learning courses as well to help developers with more education and training on security findings. And now I will hand it over to James to take you through the rest of the webinar and demo.
Thanks, Ashutosh. Let's see, I think now I can share my screen. And we're going to pick up on building feedback into the CI pipeline. All right, so here you're going to learn about how Coverity can provide feedback to developers as part of their day-to-day workflow and experience. So we're talking about shifting left, right? We want to find these potential security vulnerabilities as close to their point of introduction as possible. Ideally, inside the IDE as the developer is ideating on and creating the code. But definitely before it gets into production, right? This is going to lower the cost of fixing the issues because the impact is reduced. And for example, if we find it in the IDE, the code is fresh in the developer's mind. It's really the ideal place to catch these things. And by catching these things early, developers will benefit from the ability to move faster, right? Because there's always that helpful friend looking over his shoulder to make sure that we catch these things, and so they can move faster with that confidence. And ultimately, this is all about delivering a better product to market and preserving, the business's reputation. All right, so feedback to developers. We can do this in 2 different ways that we've already hinted at. One is going to be in the IDE as the code is being written. And then the next, we're going to apply the same technology, the same methods to find these things as part of a review process. Specifically, we're going to look at how this fits into a pull request workflow, which is today, really, I think the most common source code management methodology we see in use in the market and by our customers. So let's start with a little workflow. All right, so imagine in a DevOps pipeline, right, you have plan, code, build, test, and so on. We get into production. We're going to focus here on the coding stage. So as we receive a code change, the developer may be working on that in their IDE, at which point we run a just-in-time analysis, right? We only analyze the changes, so it's really fast. And you'll see, we're typically able to find mistakes in the developer's changes within a matter of seconds as they're working on the code. Just runs in the background, it's very unobtrusive. But we might not catch everything there. Or maybe you have a developer who's not using an IDE that we support. Or maybe they're using a command line or kind of a hardcore developer. In this case, we also integrate into the pull request workflow, right? This is pull requests. If you're not familiar, this is a concept introduced by distributed version control systems that allows an easy way to have developers work on a change and submit the change to the code owner. This is also an important complement to the IDE plugin because this is enforceable. We can't really enforce that every user always runs static analysis, runs this in their IDE, but we can enforce that every change before it goes to production is going to run through a peer code review and a static analysis. So with this system in place, in the ideal case, we find things super early, but we still catch things before they get promoted into production. So security weaknesses are going to be blocked from propagating upstream. So for feedback in the IDE, we're going to show you the Synopsys CodeSite IDE plugin. This answers the question, is there, this Coverity tool looks great, but is there a way I can find security weaknesses and coding mistakes before I even check in the code? Can you help me find things as I'm coding? It's really simple. All the developer has to do is install the plugin, and this can even be automated by the IT team. And all they have to do is open a file, work on some code, save the file. Everything else happens automatically. It will scan in the background for coding mistakes and potential security vulnerabilities as the code is being written. Let's start with the system architecture. So what do you get? What are the moving parts for CodeSite? Well, obviously the main part is the IDE plugin. This is going to run in on the developer's computer. This can run standalone, in which case it's only one user. They get the benefits of static analysis. But ideally, in a team, we will also be running the Coverity analysis as part of the CI pipeline. And the benefit of running Coverity as part of the CI pipeline is that we get to take advantage of incremental analysis. And so imagine that a developer makes a change, a typical change set, maybe 5 to 10 files, that's about it. Well, we don't want to have to reanalyze the entire program every time. But if we have the project being analyzed in the CI pipeline, that's going to analyze everything. So all the developer has to run on his desktop is he only needs to test the change files. Everything else is cached by the CI pipeline. And so the developer gets results a lot faster and doesn't have to bog down his computer with analyzing the whole program. And so we get the feedback directly into the developer's IDE. It is supported by running a full analysis in the pipeline. And if there's anything that's missed in the IDE, it's passed back through email or Slack or Jira alerts back to the developer sort of out of band. So we don't miss anything. CodeSite supports all the popular IDEs, right? We support Eclipse and compatible IDEs. There's a number of variants of Eclipse. For example, in kind of embedded device programming, the Wind River Workbench is a version of Eclipse that's compatible. We support Microsoft Visual Studio, and I believe in Q1 of this next calendar year, we will support Microsoft Visual Studio Code. They're very different platforms. And we also support the entire family of JetBrains IDEs. So that's IntelliJ for Java, I believe it's WebStorm for JavaScript, PyCharm for Python, and so on. There's about 6 or 7 different IDEs for different languages from JetBrains. Now, I'm going to show you a demo, but just so we don't miss anything, I want to show you, explain what you're going to see. This is a screenshot of Coverity with CodeSite in the JetBrains IntelliJ IDE. It's looking at some JavaScript code in this case. The things you'll want to look for is within the text editor, this main editor window right over here. You'll see these purple lines. This is kind of a heads-up display so that as the developer is writing code, these messages show up in their text editor so that they can see what the issues are that they've introduced, and it sort of explains how the defects can manifest. Over here down on the bottom this is all CodeSite, this bottom panel here. And on the left bottom, we have the list of all the issues found. Although we highlight them in the editor, it's very helpful to have a list, right? So you can double click into each of them. And then in the other panels, which I'll save for the demo, we will show the developer everything they need to understand, what the issue is, how they should fix it, and then apply the fix. And I think I'm going to save the walkthrough of all this stuff for the demo. I think it'll just make more sense. With that, I would like to show you Synopsys CodeSite. And what we're going to do is we're going to play kind of a day in the life of a developer as I work on a JavaScript, JSP, Spring application, a pretty typical web stack. We're going to introduce a security weakness, and we'll see how the whole thing works. All right, so what I've got open here is this project is called Insecure Bank. You may have heard of it. This is just sort of a known dummy application. It looks like a banking application for an online bank, but it's full of example programming mistakes. Like it's intentionally insecure, basically. So what we're going to do is we're going to introduce a cross-site scripting, and we'll see how the plugin works. All right, so here's my text editor. You can see I've already sort of prepared this. I've set things up a bit, save some time. So what this code does is this is allowing the user to upload a certificate. Right? A certificate that might be used to prove their identity for a banking application. Now, normally, the application will just return the message that the certificate, has been uploaded successfully. Easy, done. That's what it does now. Well, we're going to change it. And what this change is going to do is it's going to reflect the file name in the message. So it's going to say the file or the certificate. Let's change it to certificate. The file name is then uploaded successfully. Now, this is trying to be helpful, but the problem is because this file name came directly from the user through the web browser, it could be malicious. And so we don't know what's going to happen if this gets reflected back in the HTML to the user. It could create a potential security weakness. Let's find out. As a developer, I've just made a change. All I do is I hit Apple S, I'm on a Mac, to save my file. And now that's a signal to CodeSite that I'm done. Right? Hey, if you save your file, that probably means you're at a good stopping point, and that's our cue to run the incremental analysis. So we're only looking at this one file because that's all that's changed. And in fact, look what just popped up. It took about, I wasn't really counting, but certainly less than 10 seconds to run the analysis in the background and surface this. You can see the little message that popped up here. That this is in my heads-up display that I have an issue. Now, when I click on this, let's make this a little more, my font's really big, so I have to play with this a bit here. This tells me that a user could execute arbitrary JavaScript on a web page, allowing these various impacts. It links me to information about the CWE. In this case, there's not a linkage to the SISC standard. This is unrelated to data protection, but it's also explaining how to fix the problem. So this says, okay, so to resolve this issue, I would perform the following escaping in this order to guard against the attack. So basically, I'm missing, I'm missing this. So I need to escape this. So all I do is escape HTML. Oh, looks that's being helpful. And I'm going to escape the file name. Now when I save it, this is going to verify my fix. So again, it's just running in the background. The cue was that I'd saved the file. And what we should see is this issue will disappear from the list. It gets removed from my heads-up display. Indeed, that's exactly what happened. So it looks like I'm done. So now what would probably be next is once I'm satisfied with my code change, I would submit this via a pull request to my SCM system, in this case Git, and it would make its way into code review, perhaps it would make its way into dynamic testing, and then ultimately into production. So by doing this, I've been able to catch these programming mistakes before the code ever gets submitted, it gets propagated into the pipeline. And that's it. CodeSite is super easy to set up. All it requires is a username and a password to our service. And then this is the entire experience. So what I'd like to do is come back, and the next thing we're going to look at is, well, what happens if the developer does not do this, and that same programming mistake makes it into the pipeline? And that's where we're going to catch it with a pull request. And then we'll pause and take some questions. All right, back to the slides. All right, so I really like this diagram. This comes from GitHub, and what this is showing is the way a pull request works, but we've inserted Synopsys security testing here. So if you're not familiar with a pull request, this is a workflow whereby a developer or a team, the first thing they're going to do is create a branch from the code base. Let's call it a feature branch, right? They're creating a branch, and this is where they're going to add the new features and capabilities that they're planning to deliver. So we create a branch, we start to make some code changes, and we add commits to the system. And once I'm done, I've probably done my own testing, right? I've run it myself, run some of my own tools. I'm ready. I feel good. Now I'm ready to submit this to the owner of this code base. And we want him to accept it, and which means it would get propagated into the next stage of the pipeline. So this is where I send the pull request. It's kind of backwards. We are asking the code owner to pull my change back into the master. So see it kind of branches and then it gets pulled back into the master. Now, what typically happens is, in most cases, this is a great opportunity for a peer code review. And that's what you see in this discussion here, right? This is typically where you have a more senior developer look at the change, maybe sign off on it. There's some discussion, some chat. This is because this is already developers already expecting feedback on the change. This is the ideal time to run automated testing. So in addition to the peer code review, we're also going to run the Synopsys. In this case, we're going to run Coverity. But you could imagine we could also run any other number of automated testing types at this point. And then anything that automated testing finds just becomes additional feedback for the developer, just as if they'd received it from a peer. And then once everything is addressed and the code owner is ready to accept this, it's going to get merged, or it's going to get pulled and merged back into the main line and probably progress to the next stage of the pipeline. It's a really elegant system. And so what I'd like to show next is how this works in GitLab. But I want you to rest assured that this workflow, this works in GitLab, this works in GitHub, this works in Jenkins, this works in Atlassian, Bitbucket, and this also works in Azure DevOps. It's all the same pull request workflow. And the examples I'm going to show you there, the implementation is a tiny little bit different, but the same workflow is available in all popular SCM systems. The example we're going to use, though, is GitLab. All right, so here, same project. We've got insecure bank, and we're going to be dealing with the exact same security weakness. Just imagine that the developer hadn't benefited from having CodeSite, and the defect makes it into production. Or makes it into SCM, I should say, and then makes it into the into this workflow. I'd like to show you really quickly how this is set up, and then we'll look at what it looks like, what the experience is like. I won't go into too much depth in the how it's set up, but I think this is relevant. So many of these contemporary CI platforms, they're all oriented around configuration as code, right? And configuration as code is important because it's code, it can be versioned, it can be tracked, it can be commented, and it's also very easy to template, right? So you create a template and then you derive different versions from that through different projects. It's really become the preferred way of managing these pipelines. And so what we're looking at here, this is a little bit technical, is the GitLab CI configuration for this project. And in this pipeline, we have 3 stages, and they're not always all going to run. The first is just to build the software. It specifies a Docker container, and it specifies a command that's going to run. All this does is this builds the Java project. Pretty simple. The Polaris stage, this is going to run perhaps nightly, let's say at 4 a.m., to analyze the entire code base, every single file, so that when a developer makes a change, he only has to analyze the changed files. It'll just pull in, like from a cache, everything from this nightly analysis. Again, same model. We have a Docker container that has all the Coverity tools, and there's a command that analyzes the entire project. Now, the real magic, though, for the pull request is here. At this stage, this is only going to run when a merge request is submitted. Similar model. Oh, this is what this here says. It only runs when a merge request is submitted. Similar model. Again, there's a Docker container which contains all the Coverity software, and there's a series of commands that run. It's really not that complicated, though. I know there's a few commands here, but I can just group them together. This first set of commands, what this is going to do is it's going to determine the files that have been changed. Because again, we don't want to analyze the entire code base, just the changed files. And so this is really just some magic that's specific to Git that will, through some Git trickery, determine which files have changed and then limit it to only the source code files, because that's all we care about for code analysis. The second piece, this is going to run you can see this is similar to these previous Polaris commands, but it adds incremental, and it's only going to run on the changed files. Okay, so it's the same idea, but we're going to only look at the changed files, and we're going to get the results just for them. And then lastly, and this is where it really gets specific to GitLab, this last step is going to search through the output, and for anything that's new, as in it's never existed before or it's completely new, newly found, it is going to create it. It's going to import that issue into GitLab. So what this means is that developers won't have to come to a Synopsys proprietary interface to see the results. So let's take a look at, and that's really important. I think that's the most important thing here. And I'm going to show you what this looks like. So let's rewind a bit. Imagine that the developer did not run this in the IDE. So that very same cross-site scripting, this one right here, made it into Git, and then we're going to catch it here. All right, so I've already run this, so we don't have to wait for anything. It's sort of like the magic of television or the cooking channel. And the way this would work is I would create a new merge request. I would select the branch that it's from, but I've already done that. So let's just skip ahead and see how this looks. This is the update to dashboard controller. When I open up this merge request, so this is where the peer review happens. This is where the discussion about the issue happens. You can see I can leave comments on the issue. I can have a whole discussion thread here. But this is also where we report security findings. So this is from GitLab now. Keep in mind, this is the GitLab interface. This has nothing to do with Synopsys, right? A developer is able to just stay in GitLab and see, security scanning detected 2 high severity vulnerabilities out of 7. So it looks like cross-site scripting was one of them. It looks like there's some others, but let's take a look at what this cross-site scripting was. Now again, completely staying within GitLab, I'm able to see almost all the same information that I saw in CodeSite. I see that an explanation of the issue. It tells me that user supplied data was inserted into a context that could execute JavaScript. In other words, a cross-site scripting. And it explains how to resolve the issue. Now, I admit it's not as nicely formatted with bullets and bolds and italics as CodeSite, but we're working with what we have. So now, at this point, the developer has everything they need to understand the issue and make a fix. In this case, the fix would be the same, right? He would go into his feature branch and he would change it to add the escaper, and then it's fixed. And it would be, at that point, it would be passed through the system. But I can also dismiss the issue. I can create a work item to track it within GitLab. Everything here stays in GitLab. So what we've done is, rather than divert users to our proprietary, admittedly proprietary user interface, which is great, right? It provides lots of information, it's comprehensive, but in order to reduce friction, we're meeting the developers where they're at, right? They're already using GitLab, so we're providing nearly all the same information in their native environment that they're already using. So they don't have to get bumped over to a different user interface. They don't have to learn a new set of terms. They can stay and do everything the way they have been. And that's really the value of this type of integration. In addition to preventing the issues from propagating, we're meeting developers where they're at and trying to just not get in the way. And that's it. It's really super simple. I think at this point, we have concluded our content. And are we going to go to some questions?
Great. Yeah, thanks. Thanks for that walkthrough, James. Yes, questions, sure. A couple did come in. Is it just one plugin that I need to install in my IDE to have the security scans popping up? Is it free? Are there any paid solutions? What are the advantages of those tools? Do you want to talk a bit about that?
Yeah, it's a good question.
Plugin? Yeah.
So maybe I can address the first one first. Let's see, I'm looking for the plugins. So it's just one plugin. So the nice thing here is that Synopsys offers more tools than just Coverity, but the CodeSite plugin supports all of them. So it's only one plugin for all the Synopsys technologies. And the way I install this is we have a single, each IDE has its own respective marketplace, or app store basically, right? This is the JetBrains marketplace. And there's a single plugin to install, and with this plugin installed, it's able to support Coverity, it's able to support Black Duck, and our, the variety of our testing technologies. It is, at this point, it's a completely commercial solution. So you can install the plugin, but it requires a subscription to our service. It requires a license and a subscription to our service. Were there other aspects to the question? There were a few in there.
Yeah, sorry. So the first one, I think you just answered, is it just one plugin that I need to install? And then questions about free, paid, and then some of the advantages. If there's any differences.
Maybe one thing I can mention is that while the plugin is not available for it, given that we're talking about open standards, and there may also be some folks in the audience that are working on or contributing to open source projects. While Coverity is commercial software, I'll just put a plug here for scan.coverity.com. What this is a free site where we make, if you are like the maintainer or a key contributor to an open source project, we allow these projects that are truly, I guess the term is genuine open source, like open source compatible license. Yes, it's really an open source compatible license. then we allow these projects to use Coverity for free. Now, it doesn't use, I don't think that it supports CodeSite, but I just wanted to put that out there because there was a question about, free, paid, whatever, and hopefully that helps.
It does, thanks. Great. Oh, and he says thank you. Great. And then a question came in. I think this has to do with the new data protection measure that we've been working on. Do you see a need for a possible compliance standard? And maybe I can address that a bit. So we've been developing these product assessment standards, right? These code quality standards, the ILITs, security, reliability, and data protection being the latest in our set of standards. And really that's coming out of the need we're seeing for greater controls around data privacy and protection. You think of GDPR and California's TCPA at the state level. And we see this standard being useful for organizations that are undergoing assessments to make sure that their software, their code, does not have these weaknesses that are known to cause data protection issues. So we do see a need for compliance standards around this, around actually assessing the product itself, its code. So thanks for asking. And I did pop a link in the chat box if you want to take a closer look at our work on data protection and the other quality measures. And a question related to standard support by the tool. It's great to learn about the standards supported by Coverity. Can you tell us a little bit about the process of creating custom rules or policies to fail a build and pull request?
Sure. Let's see. I think I may even have, I don't have an example I can show on the screen. The example that we showed was very nice, right? It is identify if there's any new issues present in the code. And that's often what customers start with. But what you might imagine is maybe the policy is if there's anything matching the data protection measure, then to fail the build. The way this typically works is it's a little different in GitLab. In GitLab, we would add some filtering on the command line, right? Where you saw a series of commands that we run to just pull out all the newly introduced defects. The command line would look a little bit different there. In other platforms, and for example, in Jenkins and in Azure DevOps, we have a graphical user interface that lets you create different policies. So GitLab just tends to be much more configuration as code and sort of highly technical, but the other platforms such as Azure DevOps and Jenkins tend to be more graphically configured these days. I'll actually try to spin up, maybe as we take on some more questions, I'll see if I can bring up an example of that.
Sure, thanks. And then the question here, the code site, super helpful plugin for developers, working in the IDE. Can you talk about how developers can use incremental scans from their desktop? Yes, I think so the incremental scans, well, we demonstrated incremental scans in CodeSite, which runs on the desktop. There's other ways to do this. Like, it's not just and I think that might be what the question is getting at, is it's not just limited to CodeSite, right? We have many users who are command line oriented or use sort of programmers text editors like even Emacs or VI or, any number of things. And the same functions are available from the command line, and to some degree, they even integrate with those editors, right? It typically only reports it as sort of a compiler error,
so at least the editor can point to the line of code that it's on. So it's something. I'm not sure what the question was asking though, since we did show the incremental analysis on the desktop.
Thanks. Yeah, and just if anyone wants to elaborate, feel free. I'll circle back, but I think we covered that piece. Do you need to run full scan in CodeSite to create a reference for incremental analysis, or can it pull the most recent analysis from the server?
That's a good question. Actually, could you repeat it just to make sure I got it?
Yeah. Do I need to run a full scan in CodeSite to create a reference for incremental analysis, or can it pull the most recent analysis from the server?
Well, it can do both. So CodeSite can work in a completely standalone mode. Like if you had one developer working on one project or many projects without a team, then CodeSite would need to run a full build analysis on the desktop, so it has a reference. So they kind of run that once, and then as they make changes, it's relative to the full analysis. Or if they're in a team, that's when we set up the pipeline to, I think the example I used was maybe every night at 4 a.m. or sometime, run a full analysis. And it doesn't even have to happen necessarily every night, just as long as it happens regularly. So it can work in both ways. And Tracy, I came up with, I think I have something I can show about configuring a policy that's a little more graphical. Let me show this real quick. So where GitLab tends to be more command line driven and configuration as code, in platforms like Jenkins and Azure DevOps, they tend to be a little more graphical. And here, this is an example of our CloudBees Jenkins plugin. And so you can see this is graphical. This says that during the build, we're going to execute the Coverity static analysis. Unfortunately, I don't have everything set up, but I think I can show this to you. What I want to show is we're going to check for issues, and these are the different policies that I can pick. Now, I've configured these by hand, right? So, for example, if I selected OWASP top 10, then it would look for if there were any defects that were contained within OWASP top 10, that would fail the build. Actually, it would mark the build as unstable. I can choose. Many customers actually don't want to, quote unquote, fail the build. They just want to flag it. They don't want to like abort everything, just flag it. So often we see a policy configured, and then we mark it as unstable and notifications are sent. But we can also create a policy in here. This isn't actually coming from the product. This is just policies that I've set up for demonstration purposes. I could create a policy here for the data protection measure. And so then if the policy would be if anything matches the data protection measure, then fail the build. Right. So I guess to sum up here, it varies based on the platform you're using, whether it's GitHub or GitLab or so on. This is just, I think, an easier one to visualize.
Thank you. You know, we do have a poll here that I can shoot out. This is a follow-on. Here we go. If you'd like some additional information, feel free. You know, you can take the poll here, and we'll feed this back to Ashutosh and James about the Coverity product. You guys can see that, right? I think I showed that
I can see it.
Screen. Awesome. Okay, great. Yeah, some folks are checking off. Okay, good. Well, I think we answered all the questions here. I'll leave this open for a moment, and just a reminder, we have a copy of the slides in the handouts tab. We took a recording today, so we're going to get that posted up on the SISC website on our webinar page, and we'll send an email to everybody so you have a copy. But James and Ashutosh, thank you so much for showing us how Coverity works, you know, in the context of these measures and implementing it into the pipeline. This is fun today. Thank you.
Great.
I guess we'll give everybody a few minutes back, maybe 10 minutes back. Appreciate your time and hope to see you at a future webinar. And thank you, Synopsys, for your support and contribution. Have a great rest of the day.
Thanks, everyone. Bye.